Okay, let me write down the integration by parts formula again. Integration of u dv is equal to uv minus v du. Okay. Now if you look at this integral, you can't do this by substitution. Like if you differentiate sine, it doesn't become x. If you differentiate x, it doesn't become sine x. Okay. So actually, typically, when you know that like substitution is useless, it's usually by integration by parts. Okay. Now, we have to make one of them to be u and one of them to be dv. Usually, not always, but most of the time, a straightforward question will we pick the u to be the function when you differentiate becomes something simpler. Okay, so if you differentiate x, you get 1. It's simpler. If you differentiate sine of x, you get cosine. Is that simpler than sine x? No, as a function, it's about the same, right? So that's why we pick u to be x and dv to be sine of x dx. Okay, so we identified that to be this, okay, and this thing to be dv now. Okay, so what do I need? I need uv, so I need to integrate this. So that's going to be a minus cosine of x, and I need to actually differentiate the u from here for that part. Is that clear? So once, okay, this is I actually do this by more visually. I list out the u and dv on the top, okay, and I know that this will change like this. I multiply these two and these two. I just remember the pattern. Like these two will go, so this will become u times v, which is x times minus cosine of x, and then minus the integral of multiplying these two. So it's a minus of cosine x dx. Right, so keeping some sort of a visual pattern like that, you can do the question a little bit faster instead of trying to match this pattern exactly every single time. Okay, by letter by letter. So we have x cosine of x plus the integration of cosine of x dx. So now it's going to be sine of x plus some constant. Okay, so we have our antiderivative.